Again, welcome to another edition of Backyard Mathematics. And so here we are looking at direct sum. For instance, if you look at Euclidean space, which we know x, y, and z would represent the points in Euclidean space, that can be seen as a direct sum of the z-axis and the xy plane. And so we can also think of the homomorphic relationship here and just say R3 is equal to a direct sum of R and R2. You can also do a direct sum for R3 in a different way, but time doesn't allow here. Notice that R intersects R2 at the origin 0, 0, 0. A good way to look at an analogy here for middle school math is to think of the LCM. So if you look at the LCM of 21, you have 7 times 3 is 21. So 21 can be had as an LCM only if we take the direct sum, in this case product, which I actually write as a dot D, of 7 and 3. And we want to look at another example in which one of the numbers is not prime. So 8 and 5, 8 is not prime, would have the LCM would be 40. And again, this happens because this is the only way you can get an LCM of 8 and 40 if you take the direct sum of 8 and 40. And now this direct sum doesn't necessarily mean you're adding, as you can possibly see here. So in this case, our direct sum is a product. And so 7 times 3 is 21. That's the only way you can get the LCM of 7 and 3 if you multiply those two numbers. And for 8 and 5, if you multiply 8 and 5, you get an LCM, which is 40. This happens obviously because the GCF of N and M is equal to 1 in these cases, all right, as you can see here. I hope you can see the similarity between the concept of the 0 being the only intersection of R and R2. And here, N and M has only 1 as the greatest common factor. So hopefully you can see some relationship here in this short video.